Hey everybody, we're going to do another video. We're going to take a look at the distributive property and then using the distributive property to simplify variable expressions. Our expressions are only going to include a single variable. It might be x or y or z depending on the expression, but there's not going to be like one that's got an x and a y in it this time. But we're going to start with this little example we have on the board. Negative 2 times 3x plus 5. And of course 3x means 3 times x. And that's really important because we cannot do anything with the 3x plus the 5. Because we can't do 3 plus 5 and call it 8x because order of operations tells us that multiplication has to be done for addition, before addition. So we can't do 3 plus 5 and then multiply by x. That'd be outside the order of operations. Another way to look at it is, this is a shorthand cut way of saying x plus x plus x plus 5. That doesn't give you 8x. But I think the best way to perhaps do it is to realize that this multiplication has to be done before that addition. Okay? But that seems like we're stuck. And rather than just proving it to you and showing you that it does actually work, there's this distributive property, is what it's called. And if you want to, check it further, but the distributive property says that even if I don't do what's inside the parentheses first, because that's, again, back to the order of operations, we can do this little multiplication outside it using this thing called the distributive property. It says that if I multiply by each part of the expression inside the parentheses, I'll get the same result as if I was able to do the addition here and then do the multiplication. So now it just becomes a matter of being careful. Okay? Negative 2 times 3 is negative 6 times x is negative 6x. And then we have plus negative 2 times 5. And that's negative 10. Okay, now technically, that is correct. Negative 6x plus a negative 10. But here in the Hillcrest zone, we do not like to have what we call double signs. And we've done this in the past with another video if you want to check out that. But plus a negative 10, okay, on the number line, addition moves you to the right. But that's when you're adding a positive number. So I can't move to the right to add a negative, so I'd have to go to the left, which is really subtraction. So we just want to call it negative 6x minus 10 because that is what you're doing. You're subtracting 10, even though it started as plus a negative 10. All right, so I stop right there because just like when we had it inside the parentheses, I cannot do negative 6 minus 10 because I have to do that multiplication first. Okay, so I can't do the subtraction. So I just stop at negative 6 times x minus 10. All right, so that's the basic mechanics of it. I do want to show one thing that you can do to perhaps avoid having to worry about the double sign. So I'm going to do another example really quickly. Well, I'll just redo this one. Let's look at this. I'll rewrite this one. Okay. When you go to do the distributive part, okay, if we look at this as a plus 5 instead of adding 5, Okay? All right, we still get our negative 6x. But now we say negative 2 times 5, that's equal to negative 10 or minus 10. So it would just come up here as minus 10. One of the things that I try to tell my kids, my students, is that addition is positive and positive is addition. They're both plus. Subtraction is negative and negative is subtraction. They're both minus. So one of the things that we try to do here at the middle school is to try to get our students to understand that subtraction and negative, they're really the same thing. If you take a calculator and you clear it and you just press subtract 10 and hit an equal sign, it'll come up negative 10. Just like if you just entered a negative 10 using the negative function. So addition is positive and positive is addition. They're both plus. Negative is subtraction and subtraction is negative. They're both minus. So if you look at it like that, okay, we are seeing this as a plus 5 as a positive number. And when we do the negative 2 times that, we get our negative 10. But it was part of an expression, so the negative 10 becomes a minus 10. So that's how you use the distributive property. And that's also a reminder about our double signs and possibly kind of getting ourselves trained away from the addition and the subtraction. So what's the purpose of the distributive property? Well, one, it gets rid of the parentheses. But what it can help us do is when we begin our simplifying expressions, our variable expressions. So let me give you an example of that. Okay, so this time I've got 3 times the parenthesis x minus 4, and then I'm supposed to add 2 times the parenthesis 4x minus 2. Okay, again, I cannot do x minus 4 inside that parenthesis because I don't know what x is, so I can't take 4 away from it. And this time, some people might try to say, well, what about it? What it's just negative 4x? Well, the problem with that is this is a multiplication problem. This is subtraction. They're not at all the same. So I can't call that negative 4x. Over here, I can't do 4 minus 1 because once again, we have a multiplication. You have to multiply before you subtract. So what's my option? The distributive property. Just use it twice. Okay? 3 times x, we don't know what that number actually is, so we just call it 3x for short. And then 3 times minus 4 is minus 12. A positive 2 times 4 is plus 8 times x is 8x. And then 2 times minus 1 is minus 2. Okay, and there we go. We've used the distributive property twice. You don't have to do this, but I do like to show these little things, especially in a beginning, like a tutorial like this. So we remind ourselves to multiply. The most common mistake is to forget to do the second multiplication and call this 3x minus 4 instead of minus 12. The last thing I want to show in this video is the second step to simplifying an expression. And that is to regroup this so that my variables are grouped together in the front and my numbers without variables, called constants, are grouped together at the end. So one thing I like to do at the beginning is to go through and circle my variables. I'm using color to make some of my colleagues happy. All right? And those are the variable terms. They both have an x. These two do not. And if you are using pencil, don't have colors handy like I do, you could put boxes around those. You'll notice that I have included the sign in front of these are called terms. The things that are being added or subtracted in an expression are called terms. The variable terms have the variables on them. The constant terms are just numbers. And they, excuse me, they're called constants because they don't change. All right? So what I'm going to do is I'm going to rearrange this. That's the commutative property. And all I got to do is make sure that if I move one of the terms, I move the sign with it. It's that easy. Okay? I want the variables to be in the front just because that's the way I like it. So I'm going to leave my 3x because it's the first one. And here's my other variable term. It's got a plus with it. So it comes as plus 8x. And what's left? Just my constants. And all I got to do is make sure the sign in front of the term travels with it. And we're going to stop right here for today. We have distributed to remove our parentheses. And we've regrouped it to get our variables side by side. Variables side by side and the constants side by side. There is another step, which I will do in another video, where we actually do what's called combining the like terms, combining the variables, combining the constants. So let me do one more. I'll try to go a little bit quicker, but that way we'll have a second little video, second little example in this video. And okay, again, what's inside the parentheses I can't do anything with because this is multiplication. I can't do the subtraction before I multiply. I can't do the addition before I multiply. So my only option here is to use that distributive property, which will allow me to take care of the multiplication with a parenthesis. 5 times 2 is 10x. 5 times minus 2 is minus 10. And here's where I'm going to avoid that double sign. 3 times minus 4 is minus 12x. So I just put it as minus 12x instead of plus a negative 12, which I'd have to then change. 3 times 3 is 9. Okay? And again, just so it shows up well in the video, my variable terms are the ones with the x's. And again, I'm catching the minus sign inside that circle. No other x terms, no other variable terms. Here are my numbers, my constants, right here. So now, I just regroup it. And once I've got them identified with these boxes and the circles, I want the red ones to be side by side. So 10x, the minus travels with the 12x, and then the minus travels with the 10, and then I have plus 9. And like I said, for this video, we're going to stop right here where we have done the first 2 parts of simplifying an expression. I distributed to bust up the parentheses, get rid of them, and that allowed me to move things around so that my like terms, my variable terms, and my constant terms are grouped together. I hope this was helpful, and again, we'll do another video soon showing what to do from here, but I just wanted to get this done now. So I hope that was helpful, and we'll see you next time.